Okay, so let's move on with Armen Aghasaryan, who is a senior researcher at Bell Labs, Alcatel-Lucent Bell Labs. And Armen, you work. I wanted to start with you just to have an idea of a panorama from the technical point of view, technology aspect of privacy. Where do we stand on which work are you working, and broadly speaking, where do you think, what are the challenges in the coming years?
Thank you for the presentation. So I would like to share with you first my understanding of the current actual ecosystem of personal data and privacy, and then I will cover privacy enabling technologies and how can they fit there. So I would like to start with a citation of Alan Westin's, from Alan Westin's book, Privacy and Freedom, late 70s. So he says, each individual is continually engaged in a personal adjustment process in which he balances the desire for privacy with the desire for disclosure and communication of himself to others in the light of the environment conditions and social norms set by the society. In fact, in Alan Westin's works, he suggests that finding this balance is a necessary element of building a democratic society and maintaining democratic processes and maintaining a personal sphere separately from a public sphere. But now, decades after this understanding, in our era of big data and cloud computing, this balance is altered, this balance is perturbed. And there is no commonly accepted tool provided to end users, to individuals, to search and to find such a balance at each individual level. A naive scenario here would be, imagine a situation where a user is proposed a large panel of privacy options. Suppose it's a social network, and then a user will decide, we can suppose the user has the freedom to decide what to publish, what not to publish, and this is the way he can find this balance at his personal level. But why is this naive scenario? Because this could be imagined in a silo system. But today, it has been mentioned already, we are in a context of big data and consolidation of personal information. So this consolidation can happen in the scope of a single service provider, like large web service providers, Google, Yahoo, etc., who consolidate different areas of their services. So video on YouTube and Google Plus and your Gmail and search, etc. So this can be done at this level of a single actor, but it can be done also across different public domains. So the famous example of Massachusetts district where public information on voter lists was sufficient to de-anonymize the Massachusetts hospital information and to identify the diseases of individuals. So this is really the effect of big data on user privacy protection, because we cannot anymore leave the user alone and to decide what to share and what not to share, because he does not control anymore the consequences of his personal data being involved in this such complex environment. So what big data refers to, it was already mentioned today, is a huge amount of diverse heterogeneous data created and collectively examined through many online sites, offline sites, large repositories. Every piece of digital data that users leaves online, their browsing experience, likes, comments, emails, searches, all this eventually gets within this gets aggregated within this large cloud of what we call big data. And what is what does not allow to have this, the control of personal data is big data analytics. So as I mentioned in this example of Massachusetts district, there are many other examples. For example, Netflix data price, which was anonymized data set that Netflix put for the community of researchers to do the research on personalization recommendation algorithms. And it was shown that this anonymized data set can be de-anonymized by using a public data set of different public data set IMDb, where users declare their individual ratings on movies, and this is sufficient to cross this data and identify each individual user's preferences, or most of the user's preferences. So there are many examples, and so I'd like also to emphasize the impact of cloud computing in this environment. So it has a twofold impact. First, it empowers the big data analytics. It makes available an unlimited processing and storage capacities made available to a larger number of actors. And this democratization of computing resources, on one hand, creates higher opportunities, higher personalization opportunities for a larger number of market actors. But also it can lead more to more privacy breaches, such as deriving a commercial value without the user consent, or even developing malicious attacks. A second impact of cloud computing is the very nature of cloud computing, which is distributed. The processing capacities and the storage capacities resources are not localized, so they cross boundaries of countries, and then it is not clear anymore under which legislations these data are protected. So this introduced an additional uncertainty for the user to, with respect to the protection of his personal data. Finally, instead of being able to tune the Westin's balance, today's end user have to choose between two extremes. The so-called privacy versus personalization dilemma. So either they expose their personal data and take benefit of personalization and get involved in this environment, and by doing so they are taking uncontrolled risks with respect to their privacy, or they hide and conceal their personal data, they get out of the system and do not get personalization. But personal data is a fundamental currency of today's of today's internet economy. If you refer to web search providers or e-commerce providers, location-based applications, all of them are fed by personal data. This economy will collapse if the personal data is not available. So the decision the end user will make in front of this dilemma does not impact only the end user. It may have consequences on the economy itself. And although the users continue by inertia to use personalization services when they have to make this choice, they today make this choice in the sense of accepting this status quo. But there are some numbers which suggest that this cannot continue forever. For example, a survey done by Eurobarometer shows that 70% of individuals have concerns about the use of their personal data. Nearly 70% of respondents to Ovum survey said that they would use privacy control to block the collection of collection and use of their data if they have this opportunity. So my understanding is that the negative consumer behavior with respect to the collection of the data and stricter regulations that foresee data controllers that force the data controllers to return the control of data to the end users can eventually significantly limit the ability of the current major players, over-the-top players, to monetize their personal data. Human instinct for safety and security can at some point prevail over the added value of the personalized services and social networks. And this may result in the pollution of big data. The statistical inference done over the big data can have less accuracy and less value, therefore. And this process can be accompanied with the emergence of tools that prevent user tracking practices, auditing cookies, monitoring personal data traffic, etc. So what is the role of telcos in this picture? In my opinion, telcos are well placed to take advantage of their trusted relationship with subscribers. They collect personal data through registration and billing, and are comparatively trusted suppliers from consumers' point of view. Unlike OTT rivals, over-the-top rivals, telcos are not wholly reliant on the tracking of personal data to feed targeted advertising. Much of the telcos' personal data is collected by permission-based methods and has higher accuracy and is actually underutilized. So telcos need to better leverage their unique assets, subscriber trust, and subscriber data. To use the subscriber data, they need to do that in a way that the trust is maintained. So first direction there could be to maintain, to elaborate more and more customized services for their customers. And the second direction could be is opening of this data towards third parties, but here they should play very, very carefully in order to maintain the trust. And this is where the importance of privacy enabling technologies comes in, because you need to have kind of technical solutions where data value is taken without some sensitive information being unveiled. So at some high level, you can imagine processing a server which needs to do some operations which are necessary to derive the utility from the data, but the sources of data need that some sensitive information is not made available to the server when this processing is done. So there are different directions in the area of privacy enabling technologies which allow this kind of functionality, and they are referred to as privacy preserving data analytics. I can mention some of categories of these approaches. One very well known is homomorphic encryption approach, which allows to do some basic algebraic operations, but considering but taking as input encrypted plain text, which means that the source data can be encrypted, so nobody can interpret the information within the source data, but some useful operations, additions and multiplication can be done at the server in a secure way. Generally, these kind of algorithms are reputed to have very high complexity. Another promising direction and very popular in the research community today is statistical perturbation techniques with differential privacy guarantees. So here the approach is slightly different. Instead of encrypting the source data, some controlled noise is introduced within the source data, so that we still keep the utility of the data when doing the processing. And what is interesting here is that by tuning the amount of perturbation introduced into the system, you can play with the trade-off between the utility and the privacy. So the less you perturb, more you preserve the utility, which goes kind of into the direction of Westing's idea of finding the balance for the end user. Another category of privacy preserving data analytics, and in this area in our small team we did some concrete work. I would call it a privacy by distribution approach, where some very lightweight encryption techniques are used, but the emphasis is not on the encryption but on the distribution. So the idea is to keep the information as local as possible and apply some intelligence which allows to do processing locally but to accomplish the operations globally. So it sounds a little bit miraculous, but the idea is that, for example, very often in personalization technologies you need to compare the similarity between two objects. So how to do that? The classical way is to bring these two objects to the same place and compare the similarity. So the place where you will bring these two objects will be able to see your objects, and the privacy will be violated. Now there is hopefully a family of techniques called locality sensitive hashing, which allows to evaluate the similarity between objects without comparing explicitly them one to the other. So doing some processing locally by kind of referring to some pivot information which is broadcasted over all the local sources, and then the similarity information can be derived locally without sharing this information with the central server. Another example of this type of system is onion routing, where where a series of nodes exchange, participate to the message sending, but in a way that only a node knows its two neighboring nodes in the road and is not able to discover the source or destination of the message. Kind of distribution which ensures privacy. Thank you.